Hello, class. Alright, so we would like to review for trigonometry, starting from number 1. It says in the right triangle ABC. So let us try to draw a right triangle. Now, I'm going to assume that this will be that particular triangle. Now, and then we here realize that C is equal to 90 degrees. So let's put C here. And I'm going to put A here and then B here, for that matter. Now, sine of A, as you can see, is 3 over 5. Since sine is the opposite over hypotenuse, hypotenuse would be 5, and opposite from A would have been 3. Then I know that it doesn't look like it, but this would be 3, 4, 5 triangle. So therefore, we will realize that this side will be equal to 4. Now, then, from angle A, cosine of angle B, notice, that means we have to look at this angle. Cosine of angle B would have been 3 over 5 once again. Therefore, the answer will be choice number 1. All right, let's continue for number 2. Here it is. So in the diagram of the right triangle ABC is the right angle. Which equation is valid for triangle ABC? Cosine of A, as we can see here, is the cosine is the adjacent over hypotenuse. So it should be B over C, not C over B. So, oops, I'm sorry, it's not it. How about tangent of A? Tangent is opposite over adjacent. So it should be A over B and B over A. That's not it either. Now, let us continue a little bit further. Sine of A. Sine of A is opposite, which is A, over hypotenuse, which is C. So A over C, that's right. C, number 3 would be correct answer. All right, let us look at number 3 together here. Now in the diagram, angle B, the B is 40, so this side is 40. That's given. Centimeters. Angle A is 60 degrees, and angle C is 90 degree angle. Find the number of the centimeters of the length side C. So now, in this case, we could have used trigonometry, or in this particular case, since this is a 30, 60, 90 triangle, we realize that this would be the double of this. This would be 2x, where this one is x. So therefore, 2x would have been equal to 80. Hence, our answer will be 80. Now, in other way of solving this question would have been something like this. Since we have the angle 60, cosine of 60 degrees is equal to B over C. In other words, we have 40 over C. That would have been our second method. Now, the cosine of 60, if you remembered, this would have been 1 over 2. That's equal to 40 over C. So by cross multiplication, we will realize that C is equal to 80. So we could have actually used a trigonometry, which we have done in Algebra 1 class. All right, let us continue on to the next question. All right, so number 4, let us try to plot all those points, all those lengths. AC is 3 here, BC is 4, and AB is equal to 5. Now, given the sine B, what is sine B here? Sine B seems to be 3 over 5, because from the angle B, opposite is 3. Hypotenuse is 5. So this becomes 3 over 5. Now, then we are looking for something else. When you look at it, notice that all these angles are A. Then from angle A, how can you have 3 over 5? 3 over 5 from angle A would have been cosine. So therefore, cosine of A would have been equal to sine of B. Notice they are complementary angles. All right, let us move on. Number 5. Now, in the diagram, now AB is equal to 8. So let us plot those things. Okay, so it's already plotted. BC is equal to 15 and AC is equal to 17. Now, what is tangent of C? Tangent is opposite over adjacent from this angle. So therefore, 8 over 15. Therefore, choice 1 would have been our answer. All right, now number 6. Number 6 here we have sine of 35 is equal to k. For what measure of an acute angle? That we are looking at sine of 35 basically has to be equal to cosine of k. Now, if you remember from the chart that's given, or as we have discussed in class relating to the this represents the complementary. So therefore, when the angles are complementary, you will realize that the values will be equal to each other. So k basically has to be complementary to 35. That means 90 minus 35. Now that means k is equal to 55. So k is equal to 55 degrees. Now, if you have calculator, you can actually check it. Put sine of 35 and then cosine of 55 and then see what happens. You will realize that those values should be the same. Now, number 7. Likewise here, when the angles are complementary from the code right here, the values should be equal to each other. So in other words, 2x minus 10, when this one is add on to x plus 10, the value will be equal to 90. Now, then when you simplify all these things, we get 3x equals to 90, where x is equal to 30. Now, there it goes. Number 8. Number 8 here, cosine of 30. What is sine of 30? Sine of 30 here is equal to 1/2. Minus cosine of 60 also is equal to 1/2. Tangent of 20, I have no idea what it is. But it doesn't really matter because it's on the denominator. You will realize that numerator becomes 0. So 0 over whatever we end up getting is equal to 0. So the final answer is equal to 0. We have 2 more questions to go. Alright, now, cosine of 30 degrees. If you remember the chart, this one was equal to radical 3 over 2, where tangent of 30 degrees was in fact radical 3 over 3. Now, if you have to multiply them together, we end up getting radical 9 over 6, which simply is equal to 3 over 6. Now, when you simplify this one, we end up getting 1/2 as our answer. Now, the last question. Yes, this was a biggie. When you try to put this one in, you will realize something like this. Now, sine of 30 degrees was 1/2. So 1/2 squared. Plus cosine of 30 degrees was radical 3 over 2 squared. Now, once you do that, then the first one becomes 1/4 plus 3/4. Our final answer becomes 1. How about sine of 45 degrees? That would be similar in one way, radical 2 over 2 squared plus cosine of 45. Same thing, radical 2 over 2 squared. Now we end up getting 2 over 4 plus 2 over 4. When you add them up, it becomes 1. Oh, wait a minute. Once again, we get 1 and 1. Let us get sine of 90 and then cosine of 90. We're going to do that right here. Sine of 90 here becomes 1 squared plus cosine of 90 becomes 0 squared. Oh, look at this. We still end up getting 1. When you square sine and cosine, given that the angles are the same, we end up getting value of 1. Now, you can try with number D and number E. You will realize that these will also be equal to 1 using your calculator. Now, then number F here, no matter what the angle would have been, by looking at all the pattern, the answer will be equal to 1. Now, here comes the part G. Show why part F is always true, meaning this one is always equal to 1. Why is that? Using a unit circle. Alright, so if you have to use the unit circle here, okay. Now, okay. So given that this is angle theta, and bring this one down. Then as we mentioned that if this point is x comma y, where the radius is equal to 1, then right here horizontal line segment is equal to x, and then vertical will be y. So we realize here x squared plus y squared is equal to 1. But x, as we remember, was, in fact, on the unit circle, was equal to cosine of theta, where y was equal to sine theta. So therefore, if you to plug in cosine and sine in the correct places, we would have gotten cosine square theta plus sine square theta, which is equal to 1. So we realize that number f is always true, and it has been shown in number G. All right, that's it. Have a nice time studying, guys.